Hi and welcome. In the previous tutorial on C# exception handling, we wrote code to log exception information to a text file, which is functionality that can be very useful when troubleshooting issues. In this video, we'll look at validating user input and allowing the user to have several attempts at entering valid data before allowing an exception to be thrown. Using the common language runtime's exception handling model can be resource intensive. Currently, when the user enters erroneous data, we are letting an exception occur, then catching and handling the exception. It is far better in terms of user experience to validate the user's input and code, and if the input is invalid, rather than allowing an exception to occur or explicitly throwing an exception, allow the user to try again. So I'm going to write a validation method to validate the user's input for the operand fields. Basically, the code in this method will allow the user to have 5 attempts at entering valid data for an operand field. On the 5th attempt, if the user's input is still invalid, the code will allow an exception to be thrown, and then the exception will be caught and handled. So let's name this method validate operand input. This method returns an integer value. So at the top of this method, let's declare 2 variables and 1 constant. The first variable is named counter. This variable is defined as an integer and is used for the purpose of counting the user's attempts to enter a valid integer value. Next, let's create a constant and name it max tries. This integer constant is used to constrain the number of attempts a user is allowed to have at entering valid data before an exception is thrown. So let's set this local constant to a value of 5. The third variable is named user input and is of type string. This variable will be assigned the user's input. So let's create a do loop. The do loop is chosen over a while loop because we need the code within the loop to execute at least once. So the logic for the do loop condition is that the loop must continue to iterate while the counter variable has a value less than the value set for the constant named max tries. Max tries has been set to a value of 5. So let's write the code within the do loop to assign the user's input, which is captured through the use of the console.readline method, to the user input string variable. Next, let's perform the validation code on the user input. We only want an exception to be thrown if the user's 5th attempt at entering valid data fails. For the first 4 attempts, we want to validate the user input so that if the user's input is invalid, we can increment the counter variable denoting the number of attempts the user has had to enter valid data. We can then output the number of attempts that the user has had at entering valid data and prompt the user to try again. So we could use the int.parse method to convert the user input string variable to an integer. But if the user enters invalid data, for example, leaves the field blank or enters alpha characters, a format exception will be thrown. So to prevent an exception being thrown under these scenarios, we can use an alternative to the int.parse method. We can use the int.tryparse method. The int.tryparse method will assess whether the string variable passed as an argument to the int.tryparse method can be converted to an integer value. If the int.tryparse method deems that the string variable can be converted to an integer value, the method returns true. The method also performs the appropriate conversion operation on the string value and returns the value now converted to an integer through the second parameter. Notice that the out keyword is applied to the second parameter. The out keyword allows for the converted integer value to be passed out to the calling method through the relevant parameter. So we can use the int.tryparse code within an if statement condition. If the user input string is valid, and thus the int.tryparse method returns true, the parameter we have named I, which is marked with the out keyword, is returned and stored in an integer variable. We can simply then terminate the validate operand input method by using the return keyword to return the valid converted user input to the calling code. If the int.tryparse method returns false, the else part of the if statement is run. Code within the else part of the if statement writes the number of user input attempts to the console screen and also prompts the user to please try again. Execution of code then resumes at the top of the do loop, which means the user is prompted for a subsequent attempt at entering valid data. Right, so if code below the do loop is run, this means the user has had 4 attempts at entering valid data. At this point, we want an exception to be thrown if the user enters invalid data for the user's 5th attempt. So we can achieve this by using the int.parse method instead of the int.tryparse method to convert the user input string to an integer value. If the 5th attempt is valid, the valid integer data is returned to the calling code. If the user input is invalid, an exception is thrown and handled. So let's ensure that the code we have just created is within a try-catch block. If the user's 5th attempt to enter valid data fails, we can catch the format exception and handle it. We can then log the exception information in the format exception catch block in the validate operand input method and then throw the exception up the stack. So let's write code to log the exception, and then let's use the throw keyword to throw the exception up the stack so that the main method can handle the exception. Note the throw keyword provides the developer with the ability to throw an existing caught exception object up the stack without modifying the exception object. Using the throw keyword is appropriate, for example, when the developer wishes to handle the exception in a method and then also throw the exception up the stack to be also handled by a method further up the stack. So I'm going to create a method that serves the purpose of writing the number of users' attempts to enter valid data to the screen. I'll name this method write attempt warning to screen. Let's format this message so the message appears to the user in red text. The message outputted to the screen simply states, "You made X number of attempts." But in the case where one attempt has been made, this message will read, "You have made 1 attempts." If the counter variable is equal to 1, we don't want the word attempt to have an S on the end of it. In all other cases, we do want the letter S to appear at the end of the word attempt. For example, you have made 2 attempts, you have made 3 attempts. So, in order to account for this variation, we can use a ternary operator within the interpolated string message. Note, when using a ternary operator within an interpolated string, you must include the ternary operator within brackets. So let's then go to our main method and integrate our new validation method into our application. So in the main method, we can now simply call the validate operand input method and assign the returned integer value to our operand variables. Let's run the code and enter alpha characters into the first operand field so that the validation code prompts us to try again. Okay, so I've forgotten something. I forgot to include the write attempt warning to screen method in the else part of the if statement in the validate operand input method. Let's quickly fix this. And let's modify the code a bit so that the user experience is made a bit better through better formatting. Okay, let's try again and run the code. Let's enter invalid data to force our validation code to prompt us for another attempt. Great, let's do this 4 times. Now on the 5th attempt, let's see if our code throws a format exception. Great, we can see our breakpoint has been hit in the format exception catch block in the validate operand input method. We are logging the exception object information and then using the throw keyword to throw the exception up the stack to be handled appropriately in the main method. So let's step through this code, and you can see that we are now in the main method where the exception is being handled in the format exception catch block. The exception is now being appropriately handled through code that outputs a message to the user regarding the nature of the exception that has been thrown. Okay, so at the moment, if the user enters a blank field, i.e., either presses enter without entering a value or enters only white spaces before pressing the enter key for one of the operand fields, or enters alpha characters for one of the operand fields before pressing the enter key, we are able to catch both types of invalid user input through the use of a format exception type filter. But at the moment, we are displaying the same message to the screen when one of these scenarios occurs. because we only have one format catch block in the main method. So if we want to handle the user entering a blank field separately from when a user enters alpha characters in one of the operand fields, we can do this by creating a custom exception. So let's add another class and call this class blank user input exception. So firstly, let's make the blank user input exception class inherit from the exception class. Let's right-click the exception class name and select the Go to Definition menu item. Notice how the exception class implements the iSerializable interface. So for this custom exception, let's implement all the constructors that are contained within the exception class. Remember that constructors are not inherited by derived classes. So if required, we need to implement the relevant constructors in our derived class. So let's paste these constructor definitions into the blank user input exception class, and then appropriately modify the constructor definitions for the blank user input exception class. We need to ensure that the arguments passed to our constructors are passed down to the base class. So we can do this in code by adding a colon to the relevant constructor definition, followed by the base keyword, and then follow the base keyword with brackets, and if required, include appropriate parameters separated by commas within the brackets. This constructor is specific to a requirement whereby the relevant exception needs to be serializable. So what does it mean when an object is serializable? Serialization is the process of converting an object into a stream of bytes to store the object or transmit it to memory, a database, or a file. With exception handling, you are able to serialize an exception so that, for example, if a client was calling code remotely, let's say a web service method, and an exception was thrown by the web service method, the appropriate exception can be serialized in the web service and sent to the calling client, where it can be deserialized and handled appropriately in the calling client code. For our purposes, we do not need to serialize our custom exception, but note that in order to make an exception class serializable, you must include the serializable attribute at the top of the relevant exception class like this. Serialization is beyond the scope of this tutorial, so I'm not going to go into a lot of detail regarding serialization. This will be explored in a later tutorial. Right, so let's integrate our newly created custom exception class into the basic calculator application. Let's write a method named checkBlankUserInput. This method accepts the user input as a string argument. The code for this method is very basic. We check the user input argument for white spaces or a null value through the use of the isNull or whitespace method, which is available in the built-in C# string class. If the isNull or whitespace method returns true, this means the user has left the relevant input field blank. So here, we can throw our new custom exception, i.e. a blank user input exception object. Let's then call this method from our validate operand input method. Let's write codes to catch this exception in our validate operand input method. Let's handle this exception by logging basic exception information. We can then use the throw keyword to throw the exception up the stack where it can be handled in the main method. Let's write code in the main method to catch the blank user input exception and handle the exception appropriately. In this catch block, let's log detailed information about the exception by using the verbose log type parameter when logging the exception. Let's then output an appropriate message to the user. We have now separated handling an exception caused by when the user enters alpha characters into an operand field from handling an exception when the user leaves an operand field blank. Let's run the code. And let's leave the first operand blank 5 times to force a blank user input exception to be thrown. And the result is as expected. Great. And if we run the code, this time entering alpha characters for the first operand 5 times, Great. Of course, we could write a more descriptive message to the screen when alpha characters are entered. Invalid input is perhaps too simplistic. But I think the basic principle of removing ambiguity when the same exception type is thrown as a result of two different causes has been demonstrated through the implementation of a custom exception. The details of how these two exceptions are handled is up to the developer and should be based on the requirement. So let's write a method that will be similar to the validate operand input method to validate the operator symbol user input. Let's name this method validate operator input. This method returns a value of the char date type if the user input is valid. The method allows the user 5 attempts to input valid data for the relevant field. If on the 5th attempt the user enters invalid data, an exception is thrown. So note the char.tryPass method is used to evaluate if the user's input can be converted into a valid char. If the user's input is valid, the C variable is passed out of the method and the char.tryPass method returns true. Further validation is performed on the passed out char variable named C in the if condition. In the context of the basic calculator application, an operator symbol can only be one of the following: plus, minus, asterisk, or /. So if the if condition returns true, the C variable is returned to the calling code. If the if condition returns false, the counter variable is incremented. If the counter variable is greater than or equal to 5, the char.pass method is used so that an exception is forced if the user's 5th attempt at entering valid data fails. If valid, a char value will be returned to the calling code. If the user's input cannot be converted to a char value, an exception will be thrown and handled. Note that we are calling the check blank user input method to check if the user has left the operator symbol field blank. So let's appropriately call the validate operator input method from the main method. Let's test the code. Let's first leave the operator symbol field blank 5 times. Great. Let's then enter an invalid operator 5 times. Great. And let's look at our log file, which is now full of data that we can examine. In Notepad, we can turn off the word wrap option so that the data appears to us in a more readable format. Excellent. We looked at an overview of how exceptions can be handled in C# through the use of a try-catch block. We created a basic calculator application. Through this example, basic exception handling code for both standard C# exceptions and custom C# exceptions was created. We discussed that both standard and custom exception classes ultimately inherit from the C# built-in exception class. We discussed that an exception type filter in a catch block should always be the most specific exception that best describes the nature of the exception being caught. This principle is of course also true when explicitly throwing an exception. We discussed and created code for throwing new exceptions through the use of a combination of the throw and the new keywords, as well as throwing an existing exception up the stack through the use of the throw keyword on its own. We looked at some of the most commonly used property members used for storing information about an exception in an exception object. We looked at code for logging exception information to a text file using the C# built-in StreamWriter class. We used the message, inner exception, and stack trace properties to access information from the relevant exception object. We looked at displaying custom user-friendly messages to the user in the event of an exception being thrown, and how we can log the more technical information about the exception to a text file. We demonstrated that validation code is better for handling user input, so that a user has several attempts to input valid data rather than throwing an exception when the user's first attempt is invalid. This is because throwing exceptions can be resource intensive and should be avoided unless absolutely necessary. I hope you've enjoyed the final part of this series of videos on C# exceptions. The next tutorial will be the 22nd part of the C# for Beginners course and will focus on file handling in C#. Please like, subscribe, share, and comment to support the channel. It will be greatly appreciated. And please ring the bell so that you can be notified of future content. Please feel free to download the code created for this tutorial from GitHub. As always, a link to the relevant GitHub repository can be found below in the description. The next and final tutorial in this C# for Beginners course will focus on file handling in C#. We are coming to the end of the C# for Beginners course, but a free advanced C# course will be created and released on this channel once the next tutorial on file handling has been released. Thank you and take care.